this problem. As you can see, this problem is the third problem from Addis Ababa University exam, and it is all about the concept of how we can use the concept of relative velocity and polar coordinate together and solve different practical problem. Before starting this tutorial, if you are new for our YouTube channel, make sure to subscribe our YouTube channel and share it for your friends in order to access every engineering problem that are very important for engineering and other grade level students. Now let's jump into this problem and show every single step on it. As you can see here, the aircraft A with radar detection. Here we have aircraft A and B, and an aircraft A move in this directions and B in this direction. It's already the radar detection equipment, if flying horizontally, is increasing its speed at a rate of 10 meters per second square. Aircraft A move in this direction with increasing speed. It has an acceleration of 10 meters per second. Its radar look onto the aircraft B flying at constant speed, which means the speed of B is at a constant speed, which means the acceleration of B is 0, because acceleration is the rate of change of velocity. Since the velocity or the magnitude of velocity, which is speed, is constant, this means acceleration is 0. So the acceleration of B is 0 because the speed is constant. So if A has a speed of 900 km per hour at an instant when R is equals to 5 kilometers and theta is equals to 13 degrees. Use the following figure and determine the following question. The first question: determine the relative velocity of aircraft B with relative to A, and B determines the acceleration of aircraft B with relative to A. They have the same question, they are different velocity, acceleration and velocity. Therefore, we follow the same procedure and solve question number A and B simply. And C, we are asked to determine the angular and radial accelerations of the aircraft. So we can simply calculate this by using the concept of polar coordinate and relative velocity of motion. But first, we are given at an angle theta equals to 13 degrees and velocity of B is 500 km per hour and acceleration of A 10 meters per second squared, and the velocity of A is 9 km per hour at R equals to 5 km per second. In order to solve this problem, we are familiar for the formula for relative velocity. The relative velocity of A with B is velocity of B minus velocity of A, which means the relative acceleration of B with A at the same time is the velocity of the acceleration of B with minus the acceleration of A. It is very simple formula, and we can simply substitute the given value here. Here are given velocity of B and velocity of A, 514 km and 900 km respectively. We can substitute the value here simply, and we will get the velocity of the relative velocity of B is relative to A is minus 316 km per hour, and we can simply convert this unit kilometer per hour into meter per second by using a unit conversion factor. You are familiar for unit conversion factor. They are very important in order to convert one unit from another unit. In order to convert kilometer per hour into meter per second, our unit conversion factor is 3.6 meter per second squared equals to 1 kilometer per hour. Since we can simply derive this conversion factor by using the relation 1 kilometer is equals to 1000 meters and 1 hour is equals to 3600 seconds, which means when you divided 1000 with 3600 second, we simply find this conversion factor. So we can use this conversion factor simply and convert into meter per second, and you will get minus 100 meters per second. If I am mistaken, you are correct by yourself. Then the angular and radial velocity of this position is calculated as here, minus 100 times cos 13 degrees. We will get this value simply. For another one, we can simply substitute the given value here. Since it is a matter of substitution, we can simply substitute the given value and we will get the unknown value simply. For the case of acceleration, we follow the same procedure as a velocity and then everything like this step. So the relative acceleration of B is equals to